The diagram here represents a proton, and we need to draw lines to represent its electric field. Since we have got a point charge, the field around it will be a radial field. Radial field meaning the strength of the field decreases as you move away from the charged object. So we can represent the field by straight lines starting from the charged object in the middle. And you can see close to the proton, the lines are close to each other, which shows a more dense field. And as you move away, there are larger distances between the lines, which shows that the strength of the field has decreased. Then we need to decide on the direction of the field. Protons are positive, so we have a positive charge at the middle. And we need to remember that the direction of field lines are defined such that they show the direction of the force acting on a positive test charge. So when you are deciding on the direction of the field lines, you imagine there is a positive charge in the field, and the direction will be the force on that positive charge. Having a positive charge at the center as well, the like charges will repel, so the positive test charge will be moving out. And we draw the lines outwards to show the field. We then need to calculate the electrostatic force on the electron in a hydrogen atom. We are given the average distance between the proton and the electron, which is 5.4 times 10 to the minus 11 meters. So, in an hydrogen atom, we have got a proton, which is positive, and around that proton, we have got an electron in orbit, which is negative. And we are given the distance between these two, which is 5.4 times 10 to the minus 11 meters. The electrostatic force between two charged particles is given by Coulomb's law. And the law states that the force is a constant times the product of the two charges divided by the square of the distance between them. Here the distance between them will be 5.4 times 10 to the minus 11, and the charges will be the charges of the proton and the electron. For both the proton and the electron, we have got the charge as 1.6 times 10 to the minus 19 coulombs. The only difference is that the proton has a positive charge, the electron has a negative charge. But to find the magnitude of the force, we just need to use 1.6 times 10 to the minus 19 coulombs. And putting the numbers in the equation, we have 8.99 times 10 to the 9 for K times 1.6 times 10 to the minus 19 squared, which will be Q1 times Q2, divided by the square of the radius, which is 5.4 times 10 to the minus 11 squared. And that gives 7.9 times 10 to the minus 8 newtons.